Hi everybody, this video is going to talk about factoring higher degree polynomials. So we're just going to look at 6 different examples here. Some of this factoring will be familiar, some will be new. So I'm going to be going pretty quick here. Please pause, rewind, and stop as you need to. Okay, so let's start with the GCF. Okay, we're going to still see GCFs. We're looking for the greatest common factor between our terms. In this case, that GCF would be a 2a squared. And we're going to be left over with a 6a plus 5. Okay, so nice, easy one. We're going to continue looking for GCFs pretty regularly when we're factoring these higher degree polynomials. So we can still have a difference of squares type of factoring as well, but you're going to see bigger exponents. Previously, we said our exponent had to be squared in order to use difference of squares. But really, it doesn't have to be squared. It just has to be to an even power, because let's factor a GCF out here first of 2. I'm going to be left with 36, which is a perfect square, c to the 4th, which is a perfect square, minus 1, which is a perfect square. So we have a difference of squares here. So I want you to think, what would we square to get 36c to the 4th? Well, it would be 6c squared that we're squaring, and then to get 1, it's just 1 squared. So remember, this would be our a value, our b value. We know difference of squares factors into a plus b times a minus b. So our final factorization would really be 2 times 6c squared plus 1 times 6c squared minus 1. So we can do the difference of squares now with higher degrees. Okay, the new type that we're going to see is a sum of cubes and difference of cubes. Similar to the difference of squares, but it can be addition or subtraction. Okay, we have a formula that we're going to use for these. So if we have something x cubed plus 27, I can write that as 2 things cubed being added together. Okay, to get x cubed, we are cubing x. To get 27, we are cubing 3. So this x is going to be the a that you see in the formula. And the 3 is going to be the b that you see in the formula. So at this point, we literally just have to plug it into the formula. So we're going to use this part. This is really just the starting form. Okay, so x cubed plus 27 would factor into this, and then our next step would be going to our formula. So we're going to plug in our a and b values. So it's a plus b, which is going to be x plus 3, times a squared, which is x squared, minus a times b. Well, a times b is just 3x, so minus 3x, and then plus b squared. 3 squared is 9, so we get a plus 9 at the end. Okay, and that's it. So that's sum of cubes when we have addition. We also have difference of cubes, which is going to be the same idea, but the signs are going to be a little bit different in our formula. We're going to have a minus here, and then plus, plus. Previously, it was plus, minus, plus. Okay, so we have 2 separate formulas. You're going to have to know the difference between those. But again, we're still trying to get the structure of something cubed minus something cubed. So 216k cubed, we can think of really as 6k cubed. And 125 is really just 5 cubed. So again, here's my a and my b value that I'm going to substitute into my formula here. So we're going to get 6k minus 5, and then a squared is going to be 6k squared, which is really going to give us 36k squared, plus a times b, so 6k times 5 is going to give us a plus 30k. And then lastly, we're doing b squared. 5 squared is 25, so we get a plus 25 at the end here. And that would be our final factorization. These next 2 are going to look pretty similar to ones that we've done before. Okay, trinomials, but now the exponents are going to be different. So I want you to be looking at the exponents for these. Anytime you have a trinomial where the exponents go 4, 2, and then you have a constant, so an exponent of 0 really, if we're considering that this is really like an n to the 0 power here, these are going to factor identically to trinomials that were squared, first power, and then a constant. So we still just need to think what 2 numbers multiply to negative 24 and add to 2 in order to factor this. Okay, well, those two numbers would be -4 and 6. So previously, we would have factored this into n minus 4 times n plus 6. But now, since it's n to the 4th power, we need to make these n squareds. Because if I think of my multiplication here, if I FOIL this together, I would get n to the 4th plus 6n squared minus 4n squared, which is going to combine to give us that plus 2n squared, and then a minus 24 at the end. The other thing I noticed and what I want to point out is we can factor this a little bit further. Okay, that's a difference of squares right there. So really, my final factored form for this expression would be n plus 2 times n minus 2 times n squared plus 6. And lastly, I want to look at a problem where it's a trinomial with an odd degree. Typically with these ones, you're going to start by just factoring out a GCF first. Okay, we're always looking for that GCF. And then what's left over inside is going to be a nice quadratic trinomial that we're really good at factoring at this point. So we need to find the two numbers that multiply to -20, add to 1. That's going to be a -4 and a +5. So our final factored form here is w times w minus 4 times w plus 5. All right, we will be having a lot of practice over this. I just wanted to give you a quick crash course over all of these basic types of factoring that are going to be coming up. So please pause, rewatch, and let me know if you have any questions. Have a great day.